Why does a tiny iron nail sink to the bottom of a water body while a massive ship continues to float? This riddle might sound perplexing at first, but the answer lies in a simple scientific principle: density. Think of density as a measure of how much stuff or mass is packed into a given space or volume. It's a straightforward calculation. Density equals mass over volume. So the big question is, does the object have a greater density than water? If yes, it sinks. If no, it floats. It's as simple as that. Water has a density of 1 gram per cubic centimetre. Now consider a small iron nail with a volume of 3 cubic centimetres. This nail might have a mass of about 24 grams, which is 8 times its volume. This means the nail's density is around 8 grams per cubic centimetre. Given that this is far greater than the density of water, down goes the nail. Now, let's turn our attention to a ship. It's a vast structure with a volume of 24 billion cubic centimetres. But wait, it's not all solid steel. The inside of the ship is hollow, filled with air, reducing its overall mass to about 10 billion grams. So, even though the ship is colossal, its mass is less than half its volume. This gives the ship a density of around 0.416 grams per cubic centimetre, less than that of water. Hence, the ship floats. In a nutshell, density and buoyancy are the key players in this game of sink or float. An object's destiny in water is determined by its density, which is the ratio of its mass to volume. If the object's density is greater than water, it takes a dive. If it's less, it enjoys a leisurely float. It's a fascinating example of how seemingly complex phenomena often have simple, elegant explanations rooted in basic scientific principles.